Our third lesson in the right triangle unit involves trigonomic ratios. We tend to abbreviate the word trigonometry as just plain trig. So we say trig ratios. Remember, please, that a ratio is a relationship between two quantities or values. We usually write it either with a colon or in fraction form. In the case of trig ratios, we always write in fraction format, and that does mean that you have to write simplified fractions. Our essential question for today is, what are the trig ratios? What is trigonometry? Well, it's the study of triangle measurement. And you're going to spend a whole semester on trig in pre-calculus, or by taking a separate course, usually very creatively entitled Trig. Most colleges require you to have trig on your college transcript. So when you're done with Algebra 2 and you're looking at what to take next, and you're looking at pre-calculus versus trig, which is a semester class, and something else, or even dropping math entirely, I suggest you look at the colleges you're interested in applying to and seeing if they require trig. If they do, you need a fourth year of math, whether you're getting your advanced diploma or not. It's really sad when you have a senior standing in front of you that can't go to their dream school because they didn't take the math that was required to get in. So be careful before you drop mathematics entirely. Now, we're only going to learn the 3 basic trig ratios in this class. When you take the full trig course, you will learn the 6 basic ratios and a lot more about trigonometry than you probably want to know. But we are going to talk about sine, cosine, and tangent in this particular unit. So each acute angle of a right triangle has the following trigonomic ratios. Sine, which is abbreviated SIN. We do not say sin. Sin is a moral concept, religious concept. It is not a mathematical idea. Even with the abbreviation, we read it out as sine. Okay? It is the ratio of the leg opposite to the angle to the hypotenuse. All right, so what does that mean? Let's look at this triangle over here on the left, and let's look at angle A to start with. Okay, the side opposite is currently labeled A. The hypotenuse is currently labeled C, and we call this last side the adjacent, right? The adjacent side actually has to help make up the angle. So if we're looking for the sine of angle A, that's going to be opposite over hypotenuse, A over C. Let's look at, and I'm going to use the second triangle on here. Let's look at angle B. In this case, the opposite side is labeled B, the hypotenuse is still C, and the adjacent side is A. All right, so sine of angle B is going to be the opposite, B, over the hypotenuse, C. Every time you work one of these problems, I want you to take the 10 seconds it'll take to identify the opposite side, adjacent side, and hypotenuse and write it. Whether you write OPP or just O, doesn't matter, but I want you to identify those 3 sides. It'll make you a lot more accurate and cut down on your mistakes. So cosine is the second trig ratio. We abbreviate COS, and again, we don't say cos, we say cosine. Okay. It is the ratio of the leg adjacent to the angle over the hypotenuse. Okay. So cosine of angle A is going to equal, let me come back up here, Adjacent is B, and hypotenuse is C. So this will be B over C. And coming to my second triangle, adjacent is A, and the hypotenuse is C. So the cosine of angle B is A over C. The third trigonomic ratio we're going to work with is tangent. It is abbreviated TAN, and we don't say tan, we say tangent. It is the ratio of the leg opposite to the leg that is adjacent. All right, so let's look at A again. Opposite, hypotenuse, and adjacent. So tangent of angle A is the opposite over the adjacent. That would be A over B. Okay, and I have redrawn the triangle to look at angle B. Tangent of angle B, let's label this one. Opposite, hypotenuse, and adjacent. So opposite over adjacent is going to be B over A. Now we often use a symbol called theta to indicate which acute angle we're talking about. So you will have a triangle, nice pretty right triangle, and let's say instead of actually labeling the vertices, they just stick theta in there. That tells you that's the angle you're interested in. Always identify the sides with opposite, adjacent, and hypotenuse. It is so easy to get things confused if you don't label your sides. Don't forget to simplify your ratios. I don't want to see 10/12. Make sure you simplify. And if they don't give you values for all three sides, well, lesson 1 in this unit, you learned the Pythagorean theorem. So you are perfectly capable of finding that third side before you do your trig ratios. Now at this point you're probably saying, how in the world am I going to remember all this? Because there's a lot of information there. And there is a mnemonic, M-N-E-U-M-O-N-I-C. Mnemonic is a memory device. And our memory device for this is SOHCAHTOA. SOHCAHTOA. If you say that over and over again, SOHCAHTOA, SOHCAHTOA, it almost sounds like a nice little chant you can get going to help you remember. So each letter represents what we're doing. S for sine, O for opposite, H for hypotenuse, C for cosine, A for adjacent, H for hypotenuse, T for tangent, O for opposite, A for adjacent. I have a tendency to write SOHCAHTOA on the top of all of my papers when I'm doing trig so that I stay on track. So let's practice. SOHCAHTOA. All right, sine of angle A. Here's angle A, my opposite, my hypotenuse, my adjacent. So sine is opposite over hypotenuse, 5 over 13, and that does not simplify. Cosine, ca, adjacent over hypotenuse, 12 over 13, that doesn't simplify. Tangent is toa, opposite over adjacent, 5 over 12, and that does not simplify. Boy, did you guys get lucky. I am going to strongly encourage you, if you have to look at the second angle in the triangle, to take a minute and redraw it. You will cut down on the mistakes you make if you're not crossing stuff off in your original diagram and writing on top of things. So now we're going to look at angle C. So here is my opposite, my hypotenuse, and my adjacent. Sine, so opposite over hypotenuse, that is 12 over 13. Cosine, ca, adjacent over hypotenuse, 5 over 13. Tangent, TOA, opposite over adjacent, 12 over 5. Number 2. I'm going to write out so, ca, TOA again. And I'm starting off with angle W. So here's my opposite, here's my hypotenuse, and here's my adjacent. And right away I notice that I am missing the hypotenuse. So C squared equals 9 squared plus 12 squared. Let's see, 81 plus 144, 225. And C is 15. Of course, this was a Pythagorean triple, right? 9 divided by 3 is 3, 12 divided by 3 is 4, so a 3, 4, 5, and 5 times 3 is 15 for the side length, reminding you of the first lesson in this particular unit. All right, sine, so opposite over hypotenuse, 12 over 15, and that fraction does simplify. Divide by 3, and you have 4/5. Cosine, ca, adjacent over hypotenuse, 9 over 15, which simplifies to 3/5. Tangent, TOA, opposite over adjacent, 12 over 9, which simplifies to 4/3. You never ever do a mixed number with trig ratios. Okay, in order to do my other acute angle, I'm going to redraw that triangle. Let's see, 9, 12, 15, W, Y, and X. And this time around, I'm interested in angle X. So 9 is my opposite, 15 is my hypotenuse, and 12 is my adjacent. So sine, so opposite over hypotenuse, 9 over 15, which is 3/5. Cosine, ca, adjacent over hypotenuse, 12 over 15 is 4/5. And TOA, opposite over adjacent, 9 over 12 is 3/4. All right, third and final. We're asked for angle L. So here's my opposite, my hypotenuse, and my adjacent. And I'm missing the opposite on here. Goodness. 34 squared equals 16 squared plus x squared. So 34 squared minus 16 squared, x squared equals 900, which is 30. Let's go back. Is this a triple that we learned? If we divide by 2, we get 8, 17, and 15. Yeah, 8, 15, and 17 is one of the triples we learned. Going back and making sure you remember from Unit 1. So sine, so opposite over hypotenuse, that's going to be 30 over 34, which simplifies to 15/17. Cosine, ca, adjacent over hypotenuse, 16 over 34, which simplifies to 8/17. And tangent, TOA, opposite over adjacent, 30 over 16, which simplifies to 15/8. Now, before I do angle M, I'm going to redraw that triangle. Okay, 16L, 34, 30, and M. And this time I am asked for M. So here's my opposite, hypotenuse, adjacent. Sine is so, opposite over hypotenuse, 16 over 34, which is 8/17. Cosine, ca, adjacent over hypotenuse, 30 over 34, which is 15/17. And TOA, opposite over adjacent, 16/30, which is 8/15. All right, take a moment to write a summary of the critical information in this lesson.